Hey guys, so today we're going to do an introduction to matrices, and the second half of our unit is going to be focused on matrices and using a matrix to represent information that will help us solve systems of equations later on. So matrices are used as a structure to organize information, very similar to t-tables, charts, graphs, and matrices is a plural of a matrix. A matrix is usually represented as a rectangular array of numbers enclosed in a single set of brackets, and it looks something like this. So if we look at the information on the left, if we want to organize the amount of time that we spent studying for math and science class before midterm and before final, let's assume that we say we're going to study 8 hours before our math midterm and 7 hours before our science midterm, and then 15 hours before the final for math and 12 hours before the final for science. All of this information can be organized neatly in a table. Instead of a table, we could also organize the same information in the form of a matrix. So I'm going to call this matrix T for time, and matrix T is going to be a 2 by 2 matrix. This is the dimension of my matrix, 2 by 2. The dimensions of a matrix is always written in row by column. So 2 rows, 2 columns, which represents the dimensions. Okay, so I'm going to represent the same amount of information in a 2 by 2 matrix, where the columns represents time spent studying for midterms and finals. Those are what the columns represent, and the rows are going to represent the 2 classes, math and science. Okay, so just a different way to organize information instead of using a table. So there are different parts of a matrix, and so we had already talked about the dimensions are always row by column, how many rows by how many columns. So if we look at matrix A underneath, the dimensions of matrix A, this is a 2 by 3 matrix because it's got 2 rows and 3 columns. And inside the rows and columns, all of these numbers represent entries. So we call each one of these an entry or an element. So they call an element of a matrix or an entry of a matrix. And each entry has a specific location. So this 4 that I just circled is in the first row, 3rd column, and that's its location. The 1 is in the first row, 1st column, and that's its location. So if we want to talk about the location of each element, let me put that here, location of each element in matrix A, which is a 2 by 3 matrix, the 1 is A sub 1, 1, which is an element of matrix A in the first row, 1st column. Okay, the 4 right next to it is an element of matrix A, so we could say its location is little a, located in the first row, 2nd column. So 1, 2. And then the 4 that I circled is in the first row, 3rd column, so we say that its location is A sub 1, 3. Okay, moving on to the 2nd row, negative 2, the location of the negative 2 is A sub 2, 1, 2nd row, 1st column. The location of 6 is at A sub 2, 2, 2nd row, 2nd column, and A sub 2, 3, 2nd row, 3rd column. So it's just the location of each element. So if we look back up at matrix T, and if I were to ask you, in matrix T, what is the element T sub 2, 1, then you would say, all right, I'm looking for an element in matrix T that is in the second row, first column. Second row, first column, that's right here. It is 7. Okay, so just different ways of identifying the location of each element. Okay, so now let's look at example 1. If I have two matrices, and they're both the same dimension, right? I have a 2 by 2 matrix and a 2 by 2 matrix. Two matrices that are equal to each other. So 2 entries in a first row, 2 entries in a second row, and the dimensions are the same. So if I have two matrices that are equal to each other, then their elements, their corresponding elements, must also be equal, right? The element in the first row, first column, they're both -3 because they're equal, so each element should be equal. And then in the first row, second column, we've got -2x plus 3 and -15, and they should be equal. So in order to solve for x, all I have to do is set them equal to each other. So if the two matrices are equal, then -2x minus 3 should be equal to -15. And similarly, the elements in the second row, second column should also be equal. If these two matrices are equal to each other, then 3y minus 12 should be equal to -2y plus 13. Okay, and what x value would make these equal? Let's solve for x. -2x equals, add 3 on both sides, -12. Divide by -2, x equals 6. And then for y, what y value will make the elements in the second row, second column equal to each other? Again, let's solve for y. Add 2y on both sides. I've got 5y minus 12 equals 13. Add 12 on both sides. 5y equals 25. And y equals 5. Okay, so if x equals 6 and y equals 5, then every corresponding element of the two matrices are equal to each other. And we're not going to write our answers in ordered pair because we're not solving a system of equations, right? In this case, x and y do not depend on each other. So it's just separate. X equals 6 and y equals 5. Now, when you have matrices and we want to add or subtract them, all we have to do is add or subtract the corresponding elements. So here I have two matrices with dimensions 3 by 1, 3 rows, 1 column. Okay, and when I add them, I will get another 3 by 1 matrix. -4 plus 3 is -1. -6 plus -3 is -9. 5 plus 6 is 11. And here's my matrix. That's all. You're just adding or subtracting the corresponding elements of the matrices. So go ahead and pause the video and then try B on your own. And then if you got it right, then you can skip over that part. And if you didn't get it right, then you can go back and watch the part that you skipped over. All right, so pause, and then once you have it, jump over to see if you got the answer correct. So for B, I have a 2 by 2 matrix. I have two 2 by 2 matrices. I'm going to subtract them, and I'm going to get another 2 by 2 matrix. 0 minus 0 is 0. -4 minus 2 is -6. 1 minus 6 is -5. And -3 minus -3, that's +3, that would give me 0. And here it is. And then for C, let's think about, is it possible to find the sum of a 2 by 3 matrix plus a 3 by 2 matrix? Okay, and let's try. If we try adding the corresponding elements, I would say, all right, first row, first column, I'm going to add the negative 2 and 1. First row, second column, I'm going to add the 5 to the negative 5. But then I have a little problem when we move on to the next column, right? First row, third column, the 6, there is no corresponding element in the second matrix, so I can't add it. All right, so when you are adding or subtracting matrices, the two matrices that you're adding or subtracting must have the same dimensions. So we're going to say, is it possible to find the sum? Our answer is no, because they don't have the same dimensions. So not every element in the first matrix have a corresponding element in the second matrix. So when we're adding or subtracting, we must have the same dimensions. And the very last thing we're going to look at is something called scalar multiplication. So scalar multiplication is simply we're taking a matrix and we're multiplying by a constant value. Could be 2, could be 5, could be -1, could be -2, etc. So kind of like a scale factor, and all we have to do is multiply every element by that constant value. So if, let's say, we have matrix B, which is a 3 by 3 matrix, 3 rows by 3 columns. Okay, and then if we want to find -3 times matrix B, we're going to have another 3 by 3 matrix. And we're going to start with the first row, so -3 times 5, -15, -3 times 9, -27, -3 times 1, -3, and then second row, -3 times -2 is 6, and we have 33, -3 times 8, -24, third row, -3 times 0 is 0, -3 times 1, -3, -3 times -15, +45, and here is my new matrix, -3 times B. That's all. So let's combine adding, subtracting, and scalar multiplication and look at example 3. In example 3 we have matrix D is a 2 by 2 matrix, 7, 2, 3, 1, and E is also another 2 by 2 matrix, 0, -2, -1, 4. And I want you to find the matrix after the following operations. So you're going to do 2 times matrix D minus 3 times matrix E. So pause the video again and see if you can do it, and then skip forward and check your answer, and if you got it right, you're good. And if you didn't get it right, then rewind and watch how I did it. So I'm going to start with 2D. So 2 times matrix D, which is 7, 2, 3, 1, minus 3 times matrix E, 0, -2, -1, 4. Okay, so that's going to give me 2D is going to be 2 times 7 is 14, 2 times 2 is 4, 3 times 2 is 6, 2 times 1 is 2, minus, and then we follow order of operations, right? We multiply before we add and subtract. So 3 times 0 is 0, -6, -3, and 12. Okay, and then I'm going to subtract the two matrices. I'm going to move over here. So that's going to be 14, 10, 14 minus 0 is 14, 4 minus negative 6 is 10, 6 minus negative 3 is 6 plus 3, which is 9, and 2 minus 12 is negative 10. So 2D minus 3E gives us this new 2 by 2 matrix, 14, 10, 9, negative 10. And that is all. So adding, subtracting, scalar multiplication on matrices. And then the next time we look at matrices again, we'll look at regular multiplication of matrices.